In this video, we'll explore what cross-sectional studies are, their applications in rehabilitation, and how to perform sample size calculations for these studies. Let's get started. A cross-sectional study is a research design that analyzes data from a specific population at one point in time. It is widely used in rehabilitation research to assess the prevalence of a condition, the impact of interventions, or associations between various risk factors and outcomes within a target group. Key features of cross-sectional studies. First, data is collected once from each participant, capturing a snapshot of their condition, characteristics, or experiences. Second, these studies observe natural variations without manipulating any variables. They differ from experimental studies where an intervention is applied. Third, cross-sectional studies are particularly useful for estimating the prevalence of a condition or characteristic in a population at a specific point in time. There are mainly two types of cross-sectional studies in rehabilitation. Descriptive cross-sectional studies. These studies describe the frequency or distribution of a condition, behavior, or characteristic. Analytical cross-sectional studies. These studies assess associations between variables, such as risk factors and outcomes. Descriptive studies focus on assessing the prevalence of a condition or characteristic within a specific population at a single point in time. For example, a study that examines how common shoulder pain is among wheelchair basketball players to highlight the need for preventive measures. In contrast, analytical cross-sectional studies aim to explore associations or relationships between variables, such as investigating whether the frequency of home-based exercise programs is linked to functional mobility in elderly patients with knee osteoarthritis. Both types of studies play crucial roles in identifying patterns and potential risk factors in rehabilitation research. When conducting a cross-sectional study, follow these essential steps. First, clearly define your research question to establish the study's focus. Next, select the population and sampling method to ensure the sample represents the target group. Then, decide on your outcome measures, which are the specific variables you plan to assess. After that, perform a sample size calculation to determine how many participants are needed for reliable results. Finally, collect your data and analyze it to draw meaningful conclusions about your research question. There are many softwares for sample size calculation. G-Power is widely used for power analysis and sample size calculation, known for its user-friendly interface. Epi Info, developed by the CDC, caters to public health research with tools for prevalence estimation. PAS offers comprehensive features for detailed sample size calculations across various designs. Stata is suitable for advanced analyses, including complex survey designs, while SAS provides proc power and survey select for statistical planning in cross-sectional research. There are several online websites available for sample size calculation, making it convenient to estimate the required sample size for your study. Tools like OpenEpi, Statulator, Riosoft, and ClinCalc offer free or user-friendly interfaces to calculate sample size based on various parameters such as population size, effect size, power, and study design. These platforms are suitable for cross-sectional studies and other types of research, providing a range of options for different statistical needs. To calculate the sample size for a cross-sectional survey, several key factors must be considered. Start with the population size, which represents the total number of individuals in your target group. If the population is large or undefined, a general approach can be used. Next, the expected prevalence or proportion estimates the percentage of individuals showing the characteristic of interest, often set to 50% if no prior data exists. The margin of error reflects the range where the true parameter lies, typically set between 3% and 5%. A confidence level, usually at 95%, indicates certainty, while the design effect adjusts for complex sampling methods. The response rate accounts for non-respondents, and, if comparing groups, an effect size might be necessary. When the population size is large or undefined, the general approach to sample size estimation involves using a simplified formula that does not rely on the total population size. This is typically done by applying statistical principles, assuming a large population, which allows for a more generalized estimation. Here's a commonly used formula for determining sample size in such cases, where n equals sign, required sample size, z equals sign, z-value corresponding to the desired confidence level, for example 1.96 for 95% confidence. P equals sign, estimated proportion of the population with the characteristic of interest, often 0.5 when no prior information is available. E equals sign, margin of error, expressed as a decimal, for example, 0.05 for 5%. If you aim for a 95% confidence level, with a margin of error of 5%, 0.05, and the estimated proportion is set to 0.5, the calculation would be like this. It came out to be 384.16, and therefore the required sample size would be approximately 385 participants. Thank you so much for watching. Please like, share, and subscribe for more videos.